Hello, class. Hope you're all doing well. One more new thing that is in your project is called the Arrhenius equation. And what this does is it couples the temperature that you get from the energy balance equation with the reaction rate. So K is a reaction rate, for instance, a conversion reaction, or in your reactor. This is simply a conversion reaction. It's a rate constant. And there's a temperature sensitivity. It's been found that the relationship between temperature and reaction rate follows a profile that looks something like this, where K, the reaction rate, increases for an increase in temperature. So as the temperature of the vessel or reactor increases, you'd be stepping along here. The rate of conversion, which would increase, it gets really interesting when there's an exothermic reaction and the reaction also leads to an increase in T, which increases the reaction, which increases T, and this kind of just keeps in a feedback loop to have more and more and more reactants for the certain types of reaction. The way that we account for this is with this equation, and so K is the rate, and this rate is calculated from A, which is kind of think about as a molecular frequency factor. That's in front of the exponential term. E is the activation energy. And then R, of course, is the gas constant. Temperature has to be in Kelvin. And combination of these leads to that reaction rate above. Oftentimes, the reaction is given with a measure at one rate relative to another rate. So, for instance, the reaction rate at some temperature T2 would be equal to some K1 that is the reaction rate at some other temperature, reference temperature 1, times the exponential of E over R times 1 over T1 minus 1. Oops, that's a T. Minus 1 over T2. So again, T1 and T2 are in Kelvin, and you can see that as you increase T2, the overall rate of K at temperature 2 would go up, following this simple definition. So it's not too I think challenging to think about how heat energy increases the vibrations of molecules, causes higher reactions. And this is one of the small piece that you will need for this particular problem.